Dear students, myself Amit Patel from SMC College of Dairy Science, Anand Agriculture University, Anand. Today we are going to discuss technology of dairy byproducts 1, in which we are going to discuss manufacturing aspects related to manufacture of caseinets. This module is module number 32 and it is part of paper number 7, that is technology of milk and milk products. In this module, we are going to discuss different types of caseinets, that is sodium caseinate, potassium caseinate, calcium caseinetes, manufacturing aspects related to these caseinetes, problems associated with manufacture of different types of caseinetes, their functional properties and nutritional values, etc. With a content of 0.7 to 0.9% phosphorus, covalently bound to the casein by a serine ester linkage, casein as a phosphoprotein is a member of a relatively rare class of proteins. Moreover, due to high proportions of essential amino acids, casein is nutritionally excellent protein. Its protein efficiency ratio reported is 2.5, which is mostly unaffected by the processing conditions usually employed during the dairy operations. So, this is added advantage for use of caseinetes in dairy and food industry. Casein has some rather unique properties and cannot be replaced by other proteins in certain food applications. Edible casein and caseinetes are long established dairy byproducts, finding use in many dairy and food products. Acid casein is insoluble in water. Its soluble form caseinetes may be preferred from freshly precipitated acid casein curd or from dry acid casein by reaction with dilute solution of alkali such as sodium hydroxide, potassium hydroxide, calcium hydroxide or ammonium hydroxide. Sodium caseinate is the most commonly used water soluble form of casein and is used in the food industry. The two main reasons for using sodium caseinate as an ingredient in foods are its functional properties such as whipping ability, emulsification property, water binding property, and its nutritional value since it has 2.5 protein efficiency ratio. Sodium caseinate is valued for its ability to emulsify fat in the production of modified dairy products such as coffee whiteners, whipped cream and ice cream. It also possesses very good water binding and whipping properties. Industries of meat processing, baking and modified dairy products are the largest consumer of sodium caseinate. The various food products in which sodium caseinate is used consist of various kinds of sausages, meat based and milk based instant breakfast, modified milk, whipped cream, coffee whiteners, non-dairy creams, desserts, sauces, soups, bread, dough, crackers, dietetic products and various protein enriched products. Other casein products used in a descending order in the food industry are calcium caseinate, potassium caseinate, other caseinetes and finally pure casein. Other soluble forms of casein are produced using phosphates, carbonates and other salts as the solubilizers. Magnesium caseinate is prepared from casein and a magnesium base or basic salt such as magnesium oxide, magnesium hydroxide, carbonate or phosphate or by ion exchange method. Compounds of casein with aluminum may be prepared for medicinal use or for use as an emulsifier in meat products. Heavy metal derivatives of casein which have been used principally for therapeutic purposes include those containing silver, mercury,
iron and bismuth. Iron and copper casinates have also been prepared by ion exchange for use in infant and dietetic products.
Now we will discuss different aspects related to manufacturing of casinates. Casinate manufacturing involves addition of alkali, in which different types of alkalis are used, such as sodium hydroxide, potassium hydroxide, ammonium hydroxide and other alkalis. Then after addition of alkali, the curd and alkali should get dissolved in each other. So, next step will be dissolving step, and the last step in manufacture of casinates will be drying. So, once the alkali is mixed with the acid casein curd, it is dissolved and then ultimately spray dried.
Now let us discuss manufacturing process for the casinate manufacturing. For the manufacturing of casinates, fresh acid casein curd is preferred over dried casein as a raw material, since the former yields casinate with blender flavor than does the later one. Casinates prepared from dry casein will also incur the additional manufacturing cost associated with drying, bagging and storage of casein prior to its conversion to sodium caseinate. However, in countries which import casein, buyers may still prefer to purchase casein and produce their own sodium caseinate rather than purchase sodium caseinate. Casein should have low calcium content, that is less than 0.15% on dry matter basis, in order to produce a caseinate solution with a low viscosity, and a low lactose content, that is less than 0.2% on dry matter basis, to produce sodium caseinate with the best color, flavor and nutritional value. Now let us discuss manufacturing aspect related to sodium caseinate. Irrespective of the starting material used, the main difficulties experienced in the conversion of acid casein to the manufacture of sodium caseinate consist of formation of a casein suspension, solubilization of casein using sodium hydroxide and drying of the sodium caseinate produced. There are certain problems involved in drying of sodium caseinates, which are very high viscosity of sodium caseinate solution of moderate concentration, which limits the solid content for spray drying to 20%. The formation of a relatively impervious jelly like viscous coating on the surface of casein particles, which impedes their dissolution on addition of alkali. So, these are two major problems which are associated with drying of sodium caseinate. But we can overcome these problems, like to overcome the problem related to viscosity. It is essential that the pH and temperature are controlled during conversion, as these two factors will influence the viscosity of sodium caseinate solution. While the problem associated with impervious jelly like viscous coating can be overcome by reducing the particle size by passing a curd water mixture through a colloidal mill prior to addition of alkali. After the final casein wash, the curd may be dewatered to about 45% solids and then remixed with water to 25 to 30% of total solids before entering the colloidal mill. The temperature of the emerging slurry should be below 45 degrees Celsius, since it has been observed that milled curd can re-agglomerate at higher temperatures. So, temperature has to be below 45 degrees Celsius. Addition of alkali. The most commonly used alkali in the production of sodium caseinate is sodium hydroxide with the strength of 2.5 molar or 10% solution of NaOH, that is sodium hydroxide. The quantity of sodium hydroxide required is generally 1.7 to 2.2% by weight of casein solids in order to reach a final pH generally about 6.7. So, the slurry sodium caseinate slurry will have final pH of around 6.7. Other alkalis such as sodium bicarbonate or sodium phosphatase may be used for manufacture of sodium caseinate, but the amounts required and their cost both are greater than that of sodium hydroxide. So, sodium hydroxide is preferred alkali for conversion of acid casein into sodium caseinate. They are therefore generally used only for specific purpose such as that in the manufacture of citrated caseinates. The dissolving time of the alkali is directly related to the particle size of the curd and the particle size reduction prior to addition of sodium hydroxide rather than afterwards produces a more rapid reaction. Consequently, the curd is passed through a colloidal mill prior to addition of the alkali. Generally, the slurry is collected in a jacketed tank provided with an effective agitator and also integrated in a circular system with a high capacity pump. The addition of diluted alkali must be carefully controlled with the aim of reaching a pH of about 6.7. Preferably, the alkali is dosed into the recirculation line just upstream of the pump. Once the alkali has been added to the slurry, it is important to raise the temperature as quickly as possible to 60 to 75 degrees Celsius to reduce the viscosity of the alkali and casein mixture. The next step after addition of alkali in manufacture of sodium caseinate is dissolving of casein. The viscosity of sodium caseinate solution is a logarithmic function of the total solids concentration. Hence, each dissolving vat must be equipped with a powerful agitator and a high speed circulatory pump. Other important factors which affects viscosity of sodium caseinate are temperature, pH, calcium content of the curd, type of alkali used and seasonal and genetic factors. Care should be taken to avoid holding the hot, that is greater than 70 degrees Celsius temperature of a concentrated sodium caseinate solution extended periods prior to drying, since it is possible for brown color to develop in the solution due to reaction between the protein and residual lactose. This reaction is known as Maillard browning. During the dissolving operation, the incorporation of air should also be kept at a minimum level, since caseinate solutions form a very stable foams. So, care has to be taken not to hold the mixture at above 70 degrees Celsius, and during pumping operation care has to be taken to prevent air incorporation in the sodium caseinate slurry, which otherwise leads to problem during drying. The next step is drying of a sodium caseinate slurry. The homogeneous sodium caseinate solution is usually spray dried in a stream of hot air. For efficient atomization, the sodium caseinate solution must have a constant viscosity when it is fed to the spray dryer. It is a common practice to minimize the viscosity by preheating the solution to 90 to 95 degrees Celsius just prior to spray drying. The moisture content of spray dried sodium caseinate should be less than 5% for satisfactory storage. The total solid content of the solution destined for spray drying ranges between 20 and 22% and only occasionally may be as high as 25%. The low solids content of the feed solution produces spray dried powder with a low bulk density. It may vary from 0.25 gram per ml to 0.4 gram per ml. Generally, pressure nozzle dryers operating at 100 to 250 bars produces a caseinate with higher bulk density than from the disc atomizing dryers. Other type of caseinates are ammonium, potassium or citrated casinates. Ammonium and potassium casinates may be prepared by a method similar to that used for the production of sodium casinate by substituting ammonium hydroxide or potassium hydroxide for sodium hydroxide. Citrated casins may be prepared by a method similar to that used for the preparation of spray dried sodium casinate by using a mixture of trisodium citrate and tripotassium citrate in place of sodium hydroxide. Calcium casinate. In contrast to the translucent viscous straw colored sodium, potassium and ammonium casinate solutions, calcium casinates form micelles in water producing an intensely white, opaque, milky solution of relatively low viscosity. Calcium casinates are much less soluble and have poor functional attributes than sodium casinates. The preparation of calcium casinate follows the same general lines as for sodium casinate with a couple of important exceptions. Calcium casinate solutions are liable to be destabilized by heating, especially at pH values below 6. The sensitivity decreases with an increase in pH or a decrease in the concentration, and it is manifested as a reversible heat gelation. During the dissolving process, it has been found that the reaction between acid casein curd and calcium hydroxide proceeds at a much slower rate than between curd and sodium hydroxide. To increase this rate of reaction between casein and calcium hydroxide, the casein may be first dissolved completely in ammonia. Calcium hydroxide in sucrose solution is then added and the calcium casinate solution is subsequently dried. Most of the ammonia evaporates during this drying process. The calcium casinate obtained by this process has moisture content of 4.5%, protein content of 84%, sucrose 5.8% and calcium 1%, with the nutritional properties similar to those of original casein. Now let us discuss other casinates. Magnesium casinate is prepared from casein and magnesium base or basic salt such as magnesium oxide, magnesium hydroxide, carbonate or phosphate. Compounds of casein with aluminum may be prepared for medicinal use or for use as an emulsifier in meat products. Heavy metal derivatives of casein which have been used principally for therapeutic purposes include those containing silver, mercury, iron and bismuth. Iron and copper casinates have also been prepared by ion exchange for use in infant and dietetic products. Now let us see composition of casinates, especially sodium casinate and calcium casinate. The quality standards for sodium casinates may vary from country to country. In this slide, the typical composition of sodium casinate and calcium casinate is shown, which were prepared from well washed acid casein. The moisture content for safe storage of casinates, dried casinates, should be less than 4%. So, in this case, the moisture content of sodium casinate as well as calcium casinate was found to be 3.8%. The protein content of both the calcium casinate as well as sodium casinate were nearly 91%. The ash content should be 3.6 to 3.8%, lactose should be less than 0.1%, then fat percentage for both the types of casinates were 1.1%. In case of sodium casinate, sodium was 1.2 to 1.4%, whereas in case of calcium casinate, it was found to be less than 0.1%, and in case of calcium casinate, calcium content was higher, that is 1.3 to 1.6%, since calcium hydroxide is used for its manufacturing. The pH of both the types of casinates were found to be 6.5 to 7.
Dear students, in this module, we have learnt about a byproduct known as casein and from which we can prepare casinate. Since casein is insoluble in water, for its efficient use in dairy and food products, it has to be made into soluble condition, and for that casein is converted into sodium caseinate with addition of alkali. After addition of alkali, the acid casein solution is converted into sodium caseinate slurry, and this slurry is subsequently spray dried for manufacturing of sodium caseinate powder. This sodium caseinate powder has various functional properties such as whipping ability, water binding capacity and emulsification properties, and because of its functional properties, it has tremendous role as ingredient in manufacture of various dairy as well as food products such as whipping cream, ice cream, sausages, soups, biscuits, meat products, etc. Thank you.